All right, let's get into it. Today, we are going to grab one of those mysterious strings of numbers you see everywhere, an IP address, and we're going to tear it apart to see how it really works. We're going from the big ideas straight into the command line.
I mean, come on. You've definitely seen this one before, right? Probably when you were setting up your Wi-Fi at home. It just looks like a random jumble of numbers. But I promise you, by the end of this, you'll be able to look at an address like that and know exactly what every single part of it is for.
So, where do we even begin? Well, we've got to start at the beginning, with the original blueprint for how the internet was organized. We're talking about IP address classes. This is the foundation of it all. Think of it like this. Way back when the internet was just getting started, they needed a way to keep things from being a total mess. So they split all the available addresses into these big buckets called classes. This system, known as classful addressing, was all about handing out huge chunks of addresses to different companies and organizations. Okay, so let's cut through the noise and just focus on the big three you'll see most often: Class A, B, and C. And here's the secret, the key to the whole thing. It's all about that very first number. If an IP address starts with anything from 0 to 127, boom, it's a Class A network. If it's between 128 and 191, you've got a Class B. And if it's 192 to 223, like your home router, that's a Class C. That one number tells you the default size of the network. Don't worry about that slash number for now, we'll circle back to that. All right, so knowing the class is cool and all, but what does that actually get you? Well, the real question is how many devices, laptops, phones, what have you, can actually connect to one of these networks? Let's figure out how to do the math.
And believe it or not, the formula is beautiful. It's just 2 to the power of n minus 2. So n is just the number of host bits available, basically the part of the address that isn't already claimed by the network itself. Now I know what you're thinking. Why minus 2? What's that all about? Hold that thought because the reason is actually pretty genius and we'll get to it in a sec. Let's put this into practice with our trusty home network, a Class C. You see that /24 at the end? All that means is that the first 24 bits are for the network, which leaves the last 8 bits all for us to use for our devices. So in our formula, n is 8. Okay, let's plug it in. 2 to the power of 8, that gives us 256. Then we subtract those two special addresses we talked about, and bam, 254. That means on a standard home network, you can connect 254 different gadgets before you run out of addresses. But what happens when we go bigger, like way bigger? Let's check out a Class B network. It uses a /16. This means instead of 8 bits for our hosts, we now have a whopping 16 bits to play with. Our n just jumped from 8 all the way to 16. So 2 to the power of 16 is, get ready for this, 65,536. Take away our two special addresses, and that leaves you with 65,534 possible hosts. I mean, wow. That just perfectly shows how a network's capacity can absolutely explode just by adding a few more host bits. Okay, so we know how many devices we can have, but what are their actual addresses? What are their names, so to speak? To figure that out, we need to map out our network's territory, find out exactly where it starts and where it stops. All right, it's time to solve the -2 mystery. It all comes down to two very special, reserved addresses that you can't use. The very first one is the network address. The best way to think about it is like the name of your street. It's not a specific house, it's the street itself. The very last address is the broadcast address. This is like a megaphone for the whole neighborhood. It sends a message to every single device on the network at the same time. Pretty cool, right? That's why you can't assign them to a single computer. So, going back to our 192.168.1.0 network, this means the address ending in .0 is the network ID, and the one ending in .255 is that broadcast megaphone. Neither one can be assigned to your laptop. Simple as that. So, what can we use? Well, it's everything in between. Your first usable address is simply the network address +1, and your last usable one is the broadcast address -1. Easy. And boom, there you have it. For that classic home network, the addresses you can actually assign to your devices start at 192.168.1.1 and run all the way up to 192.168.1.254. And that right there is where we get our 254 usable hosts. See, it all connects. Okay, theory is awesome, but it's time to get our hands dirty. We're going to take everything we've just learned and put it to work by configuring an IP address on a real network device, right from the terminal.
So check this out. Here's our setup. We've got this router, we'll call it R1, and it's connected to a massive Class A network, 10.0.0.0/8. Our mission is to give that router an IP address on its interface, so it can actually start talking to everything else. Now, when you're working with a Cisco device, there's a certain flow, kind of like levels in a video game. First, you got to get admin powers. Then you enter the main configuration level for the whole device. From there, you zoom into the specific port you want to change. And finally, you give it the address and flick the on switch.
First up, once we have administrative access, we type conf-t. It's just a shortcut for configure terminal. This command is what gets us into the global settings where we can make system-wide changes. Okay, next we have to tell the router which physical plug we're talking about. So we type interface gigabit Ethernet 0/0. This is us saying, hey router, I want to change the settings for this specific port right here. And you can even see the prompt changes to let us know we're in the right spot. And here it is, the main event, the IP address command. This is where all our theory becomes reality. We give it two pieces of information. The IP we want to assign, and look, we're using the very last usable address in our Class A network, just like we calculated, and then the subnet mask, which for a /8 network is 255.0.0.0. We are so close. There's just one last crucial step. By default, Cisco interfaces are turned off for safety, so you have to explicitly turn them on. The command is no shutdown, which is basically the power button. You type that, hit enter, and the interface comes to life, ready to move traffic. Okay, let's do a super quick recap. First, classes give you a ballpark idea of your network's default size. Second, the magic formula to find out how many devices you can connect is 2 to the power of n minus 2. And now we know exactly why we subtract 2. One for the network ID, the street name, and one for the broadcast address, the megaphone. Everything else in the middle, that's your playground. Those are the addresses you can actually use. So, I'll leave you with a little puzzle to think about. Now that you've got the tools, imagine you're setting up a network for a small office. They need to connect 50 devices. What kind of network would you give them? You don't want to waste thousands of addresses, but you need enough room to grow. It's a fun challenge, right? Hey, if this explainer helped you connect the dots, do us a huge favor and hit that like and subscribe button. It really helps us make more content just like this. Thanks for watching.